Hello everyone, welcome back to lecture 3. So today we are going to study about another continuous beam example. So uh, this is a figure which is shown. So we need to analyze this figure and draw the bending moment for this figure which they are showing. So it is having three number of spans AB, BC and CD. AB is having 60 kN load at a distance of 4 meter and it is having 1.5 I. Section property has 1.5 I. So it is 6 meter. BC is carrying uniformly distributed load of 20 kN meter. So it is having section property I and it is 3 meter. Now CD is a span which is having length of 8 meter and at the center it is carrying 30 kN load, having the section property 2I. Now first step, according to our first step, we need to calculate fixed end moments. So this document I am attaching with this particular video which shows the fixed end moment calculations. So you can see this document. So this document I am attaching. So it gives us the list of formulas for calculation of fixed end moments. So you can use this. So we will move further. Fixed end moments M, F, A, B. So from A to B. So from A to B it is minus. So WAB square divided by L square. So I have calculated like this. It is minus 26.67. Next you can see M, F, B, A. So from B to A it is plus. So it is, I have calculated like this, 64 square into 2 divided by 6 square. So I have calculated M, F, B, C. So M, F, B, C I have calculated minus WL square by 12 minus WL square by 12 I have calculated like this. So M, F, C, B. So they both are same. Minus here for BC it is minus, for CB it is plus WL square by 12. So again it is plus 15 kN meter. Next MFCD. So MFCD. So you can see it is a point load acting at the center. So fixed end moment at CD is WL by 8 and it is minus 30 minus WL by 8. Minus 30 into 8 divided by 8 it is minus 30. Similarly DC it is plus WL by 8. So it is plus 30. So you can see in this formula center, if the load is acting at the center, WL by 8, WL by 8 on both the sides. If the load is acting at a distance A from one end and at a distance B from other end, it is WAB square divided by L square. At this end, WA square B divided by L square at this particular end. If it is carrying uniformly distributed load, it is WL square by 12, WL square by 12. So same formulas we are using over here. Now as we have completed with the first step, we will move to the second step. So you can see how many number of joints are there, intermediate joints are there in this particular problem. There are two number of joints. One is joint B, another one is joint C. So at joint B you can see there are two members which are getting connected, BA and BC. So BA, BC. So BC is an intermediate beam. So stiffness will be 4 EI by L. BA is an end beam with fixed end. It is having far end as a fixed. So it is also 4 EI by L. If it is a simply supported over here, at a point A, if it is simply supported, then the stiffness would be 3 EI by L. So 3 EI by L. As it is a fixed end, I am going to consider 4 EI by L. So here AB 4 EI by L, BC also 4 EI by L. Similarly, you can see at joint C, there are two members which are connecting, CB and CD. So CB is an intermediate beam, that is 4 EI by L. CD is a end beam which is having fixed end at the point D. As it is a fixed end, again here will be 4 EI by L. So all the things are 4 EI by L. So I have added these two calculations. So this will be equal to 1 EI. So this will be equal to 1.33 EI. So I have added it and 2.33 EI I have got. So distribution, to calculate distribution factor, 1 EI here, 1 EI divided by 2.23 EI. so it is going to give us 0.429. Similarly here 1.33 EI divided by 2.33, so it is going to give us 0.571. Next here this both the things I have added, again I have got this same answer. So I have got this distribution factor similar to the previous one. So I hope you have understood about the distribution factor table. We will move further. A very important point in moment distribution method, that is moment distribution. So we need to carry out this table. So firstly we have to write the joints A, B, C and D. A, B, C and D. Next you can see distribution factors I have to write. So there is no distribution factor for A and D as they are end joints. So intermediate joints are only having distribution factors, remember this. So distribution factors are here. So according to that I have written BA 0.429, BC 0.571. So BA, BC, CB, so from C to D 0.571, C to D 0.429. So distribution factors I have written. Similarly I have got fixed end moments. So these fixed end moments I am writing over here. So this is the setup of this particular table. Now step number 1. So I have written it clearly, everything over here. Step number 1, balancing. So how you are going to balance? So I have shown the calculations over here. So step number 1 at joint B. So first of all we will consider joint B, then we will go for joint C. So at joint B you can see 53.33 minus 15. So minus 15 we have got it as 38.3. So minus sign we have to apply for the balancing. So minus 38.3 is unbalanced movement. So this unbalanced movement is to be distributed to both the ends according to their distribution factors. So minus 38.33 into 0.429 into 0.429 is a distribution factor for BA. So it is going to give us minus 16.44, which I have written over here. Similarly minus 38.3 into 0.571 is going to give us minus 21.89. So I am talking about balancing this line now. If I consider next one, I will tell you about carryover moment later. If I consider joint C, you can see here plus 15 minus 30, we are going to get minus 15. So minus 15 we have got. So we have to multiply it with the minus sign for balancing. So plus 15 we have got. So plus 15 into distribution factors. So 0.571. So distribution factor if I multiply, I have got plus 8.75 plus 6.43 plus 8.57 6.43 I have got. So this particular line is over. Now carryover moment. Half of this moment is carried over to the adjacent joint. So 16.44 divided by 2, half of this movement is carried over to here. So 21.89, half is carried over to here. 8.57, half is carried over to here. Similarly 6.43, half is carried over to here. Now step number 1 is over. Now step number 2. Again we need to find out the balancing moment. So balancing moment we are going to get directly over here. So that is 4.29 is a balancing moment. So 4.29 is plus, so we have to consider it as a step number 2. 4.29 is an unbalanced movement, we have to consider it as a minus. So after considering minus, we have to multiply these things with the distribution factors. So same thing I have done. 4.29 minus I have considered, multiplied it with these distribution factors 0.429 and 0.571. I have got minus 1.84 and minus 2.45. Joint C you can see here. So minus 10.95 is there. I am going to multiply it with the minus sign. So I have got it as a plus 10.95. So 10.95 into this distribution factor. So it is 6.25 and this one is 4. If I multiply it with this one, 4.70. So I have got this balancing moments. Again I am going to carry this half of this balancing moments as a carryover moments to the adjacent joints. So 1.84 into 0.5, 0.92 I have carried out over here. So from here I have carried out here, from here I have carried out here, so from here I have carried out here. So same step I am going to follow here and same step I am going to follow here. One thing we can observe at this particular stage is carry over movement is nearly negligible. Carry over movement is nearly negligible. We have to even carry out the movements here also. I have not shown, but just carry out them. So 0.15, so half of this movement is here. So 0.20, half of this movement should come here. 0.51, half of this movement should come here. So 0.39, half of this movement should come here. So sum all these things, minus 15, don't consider this distribution factors. So minus 15, minus 21.89, all these things, we are going to get this answer. Remember how to cross check this? To cross check this, at particular joint, both the moments from both the sides should be equal but having opposite sign. So you can see at joint C we have got same movement but opposite sign. At joint B we have got same movement but opposite sign. So this is about the distribution, movement distribution table. So now step number 4, bending moment diagram. So we know that bending moment diagram is a combination of final fixed end moment diagram plus free end moment diagram. So free end moment diagram is WAB divided by L. Free end moment diagram is WAB divided by L for span AB. For BC, WL square divided by 8. For CD, WL by 8. It is nothing but a bending moment. We have to consider the individual beams as a simply supported, and we need to calculate bending moment diagrams. So you can see the black rounds are showing the final fixed end movements, red rounds are showing final free end movements. So I have combined this and I have drawn the bending moment diagram. So this table is very important. So we need to carry out the movement distribution method. Remember, I have forgotten to write the values over here, here and here. So please write down these values. Half of this value should come over here, half of this value should come over here. Similarly, half of this value should come over here. So in next session we are going to study about the sinking support or support when gets sunk by certain amount.